Now we look at the corresponding position. Phi is equal phi x. So phi equal phi x. That means x equal 1. Y is equal 15. So that y equal 15. On the second row 2, column 1, 15 equal 15. They are equal. Z is equal phi y. So that z is equal phi multiplied by y. Y is 15. That means z is 75. Multiply matrices. Then the matrix A has an m by n. Matrix B has the n by p. So let me write down this way. Matrix A has an m by n. Matrix B has the m by p. Two matrices, in order to multiply, it neither has that type of the requirement. Now, the first matrix, the column of the first matrices must be equal the row on the second matrix. They must be equal. That's a requirement when you multiply two matrices. Keep in mind, the column on the first matrix must be equal the row on the second matrix. Sometimes people call the inner two number. The inner two number on the dimension, they must be equal. And the output, the dimension of the new output would be m multiplied by p. So that would be the product output. The new dimension will turn to the m by p. If we look at the example here, matrix A, I has 2 by 2. B, I has 2 by 1. Can I multiply matrix A to the matrix B? Yes, because the column on the matrix A is 2. The row on matrix B is 2. So they are equal. In that case, the new output, the product output of these two matrices would be 2 by 1. Now we look at the other one. What if I use the matrix A to multiply matrix D? A times D. Matrix A has 2 by 2. Matrix D has 3 by 2. Since the inner two number, which means the column on matrix A is not equal the row on matrix D, so in that case, you cannot multiply, so not possible. Because these two numbers, they are different. Now we try the other one example. We do matrix C multiplied by matrix D. So C multiplied by D. Matrix C has a size is 2 by 3. D has size is 3 by 2. Now the inner two number, they are equal. So that means they can be multiplied. The product of the matrix of these two matrices would be 2 by 2, has that size 2 by 2. So multiply two matrices, you need to consider the size, because that would be a new template, or that would be the new structure of your output matrices. Find the C equal A times B. That means we have to multiply matrix A with matrix B. And the output, the product of the output would be a matrix C. So we look at the matrix A. And by the way, when you multiply two matrices, position is a key component. Who stay in the front, that is a big matter. So you have to recognize who is the first one, which one is the second one. Put it in the right order, right? Order doesn't matter. You don't swap. So matrix A, we have row, 2 row, 3 column. So we go with a 2 by 3. Matrix B, we have 3 row, 2 column. So the size of the matrix B is 3 by 2. Can I multiply A and B? We need to look at the inner two number, which means the column of the matrix A must be matched with the row of matrix B. So since both of the inner two number they are 3, that means yes, they can multiply. And the new size, the new output size would be 2 by 2. That means the matrix C should have a 2 by 2.